Hello guys, we start new section, new chapter, chapter 15. It's called vector fields, section 15.1. First we give its definition. Vector field over plane region R is a function f that is assign vector f x y for each point in R. Example. For example, gradient is always vector fields. Let's go, we have some function xy. Today's looks like equal x square y plus 3xy cube. And then its gradient, and this function f will be 2xy plus 3y cube. This is 3, I'm sure. I plus derivative for y, it will be x squared plus 9xy squared j. Gradient function f is vector field because its function is 2 variable. This means it's vector field in the plane. If you have function 3 variable, second example, let's go with our function is z equal x squared plus y squared plus z squared. This is gradient. This function will be partial derivative for x is 2x I, partial derivative for y it will be 2y j, and partial derivative for z it will be 2zk. This is gradient. This function is will be vector field in the space. Okay. Try driving some gradient and understood what this mean. But before we need one more definition. Inverse square field. Okay, first I'm clear here. And but what kind of vector field you have in the you study in physics class? For example, velocity fields, gravitation fields, electric force fields. All is this one is will be vector fields. And one more definition. Let's go, we have RC, it will be function x c I plus y c j plus z c k. Positive vector. Vector field F is an inverse square field if f depend x, y and z will be k over square norm vector r multiplied by vector u, whereas k is a real number. Okay, guys, it's sure it's real number. And u is unit vector, is same direction like vector r. This means r depend norm vector r. Okay. Doing some example, try draft our vector field. Let's go. Our vector field is x, y. This will be in the plane. This will be minus y I plus x to the g. Let's go norm f. It will be some c. What does mean? It's mean x squared doing this one, x squared plus y squared. It will be c square root. Today is not, looks like it's not my day. Okay. And it's mean x squared plus y squared equals c squared. This mean is some same length of vector we have if our points stay in the one line, one circle with one radius. Let's go. We have radius equal 1. If we have point with coordinate 1, 0, our vector, it will be vector j. This means here. If your stay point is 0, 1, your vector, it will be negative I. This means some point here. A vector there. If you have point negative 1, 0, you have negative j. And if you have point 0, negative 1, you have I. Okay. Take it some circle, different radius. This is length circle. For example, this is radius 1. If it's radius 2, length of your circle is will be 2 unit. And here, for example, you have some vector this, vector here. Oops. Sorry. Oop. I try clear. Vector need touch your here as will be there, and this is will be there. But it's length of twice longer than unit vector. And continue. If you have circle radius 3, you have each vector will be 3 times longer than unit vectors, and because we have this kind of function. Okay. We have more definition. Okay, clear now my desk. Okay. Vector field call conservative vector fields F. Okay, I'm trying doing definition. F we call conservative. If exist function such as your vector field is gradient your function. For example, if you have vector field equal to xi plus yj, what will be a function whose gradient equal to xi yj? I think this function will be, it means partial derivative for x equal to x, looks like we have x squared, and partial derivative for y equal y. This means we have plus 1/2 y squared. This means this vector field is conservative. And here we have theorem. In the future we have some similar theorem when you take a differential equation class. We have some similar theorem, but right now we study here vector field, or you can rewrite like combination function m depend xy I plus n xy j, conservative if and only if partial derivative function m respect to y dm dy equal partial derivative function n dn dx. I think it's proving this theorem is no problem, because what does mean is conservative? Exist function such as gradient function f, it will be your vector field. What does mean partial derivative function f respect x is m, partial derivative function f respect y is n. But if your function is good enough, this means continuous or piecewise continuous, f x y equal f y x, second order derivative. It's mean derivative m respect y equal derivative n respect x. First I clear all my table. And we're solving example when we're checking our vector field is conservative or not, and how we can find potential function. This means function whose gradient exactly equal this vector field. Okay, first checking. We have some vector field f xy equal x squared y I plus xy j. Function m here is x squared y, and function n is xy. Found derivative m for respect y, you have x squared. Found derivative n respect y, you have x. Respect x, you have. Just a moment, I need n for x. Respect x, I have y. But x squared is not equal y. This means this vector field is non-conservative. Next example, let's go is f xy is e exponent x plus y squared I plus 2yx j. M here, e exponent x plus y square. Partial derivative iy, it will be 2y. N is 2yx. Partial derivative for x, it will be 2y. And this one, vector field is conservative. One more definition we studied today is Calc of vector field. Just a moment. Okay. Card of vector field. Let's go, we have vector field in space x, y. Oh no. Z. It will be some function m I plus function n times j and plus function p times vector k. Then card f vector space, vector field, sorry, this will be cross product gradient vector to f. It means you have I, j, k, d for dx, d for dy, d for dz, m, n, n, p. And how you remember, how we can rewrite, it will be dp dx minus dn dz. This is you multiplied by vector I minus dp dx minus dm dz j plus, and last one is will be dn dx minus dm dy. This is vector k. Coefficient is vector k. Okay. Solving two more example. Now I'm clear. My board. Just a moment. Okay. Here we have, it's question 44 and from your book. Here you have vector field who is equal x square z I minus 2x z j and plus y z k. This will be is m, this will be is n, and here is p. Plugging in the formula, you have card f will be zero plus 2x I minus 0 minus x square j and plus minus 2z minus 0 k. Here will be 2xi plus x squared j and minus 2zk. I'm only found partial derivative m, n, and p, independent what variable I need, and plugging in the formula. Okay. Next example, next question, and from your book. As you have vector field, and you need checking this is vector field is conservative or not, and if it found potential function. This means found function whose gradient exactly equal this vector field. We have our vector field xy. It will be 3x squared y squared I plus 2x cubed y j. First we're checking is conservative or not. This means I need check partial derivative m respect y equal partial derivative n respect x. 3x squared y squared, we take a derivative for y. It will be 6x squared y. Then 2x cubed y, we take a derivative respect x. It will be 6x squared y. Yes, we have equal. This means we have conservative vector fields, and we can found potential function. How are we doing? We try found function xy. It will be, we take a integral for m function, and variable integration will be x. This means I take a 3x squared y squared dx. And maybe we have some partial whose depend only y. This means maybe g depend y. Found this integral is no problem. We have x cubed y squared and plus maybe part depend only y. Now, because gradient need be equal vector fields, this means we try found partial derivative respect y. What is it? It will be 2x cubed y plus, because this function, second function is second term depend only y, this means it will be g prime y, and is equal function n 2x cubed y. If we're solving this equation, we have g prime y, it's equal 0. This means this part is equal some constant k. And our function, okay, I write here, f xy will be x cubed y multiplied by y squared plus, oh my god, plus k. This is our answer. I'm done for today. I try put your grade in the blackboard in Monday, and then I don't know, make presentation or only show you how it's in blackboard, how will be a right answer, right solution is your quiz, last quiz. Okay, bye.